All right, let's take a look at the other type. So we have and compound inequalities, and we have or compound inequalities. And like I told you, it's very easy to tell the difference. The or ones are almost exclusively written just with the word or separating two simple inequalities. So this is a simple inequality, this is a simple inequality. By just putting the word or in between them, that joins them and says, hey, these two are one problem. We want the answer for this one or this one. Okay, and some people see that word or and it's thinking, well, then I give you the answer to this one, and I won't have to give you the answer to this one, or I'll give you the answer to this one. I won't have to, but that's not what the or kind of means. What the or means is if it's a solution to this simple inequality, it's a solution to this whole problem. If it's a solution to this inequality, it's a solution to this whole problem. So these ones are kind of greedy, and they just take whatever they can get their little hands on. Like if it works for this one, it's good for the whole thing. If it works for this one, it's good for the whole thing. So what we do with the or compound inequality is actually just solve both of them independently and then graph both of them on the same number line. Okay, so if we want to solve this, we would just literally isolate x here. We're going to go ahead and minus 2 from both sides. So let's subtract 2. We're just looking at this first inequality. We'll get negative 4x is greater than 12. Divide both sides by negative 4. Okay, hopefully your ears are ringing right now because you're dividing by a negative number. We know that means x needs to now be less than. We got to flip that inequality. 12 divided by negative 4 is going to be negative 3. Okay, so we just solved that one. Now we're going to solve the other one. Minus 3 from both sides. We get negative 8x is less than or equal to 11 minus 3 is going to be 8. Divide both sides by negative 8. And again, hopefully something's going off inside your head here, but you divide it by a negative again, so we got to flip that inequality around. So this becomes greater than or equal to 8 divided by negative 8 is negative 1. Okay, and as far as the inequality goes, all we'd have to do is write each solution with the word or in between. And we do like to look, smallest to biggest here. So x is less than negative 3. Okay, or you have to have that word or in there. X is greater than or equal to negative 1. Okay, to graph these, the or ones, and if you think of the and ones we shaded to the middle, well, the or ones we're just going to shade to the outside. So let's put negative 3 on the number line right here, negative 1, so let's go up by 1's negative 2, negative 1 is right here. We would be open on negative 3, so we're going to put an open circle on negative 3. And then it says x is less than negative 3, so that means we're going to shade to the left, and that's all these numbers. And again, we don't need to look for overlap. We don't need anything like that. It's just graph it and graph it. The other one says x is greater than or equal to negative 1. So this one we're going to be filled in on. And then we want to be greater than that. So we're going to shade to the right. Okay. And that's everything this way. Okay. And you can see the or compound inequalities are always going to shade the outside. And that's one way to remember it. Or starts with an O, outside starts with an O. Okay, so or we're going to shade outside. The and ones, like we looked at earlier, shaded to the middle, shaded between your two endpoints. So that's just kind of one way to check to make sure your inequalities are, facing the same direction. Let's try one more here.